Coulomb's law with an equilateral triangle. This is the hardest kind of Coulomb's law question, just because of the fact that, well, if it's equilateral, we know a few things. We know that all the angles are 60 degrees. We know that they're 15 centimeters each, which means they're all 0.15 of a meter. That's great. You know, there's some knowns, but the problem with this is that when we take this -2 and this +8, I get an attraction. I get it this way. It comes along at an angle. Okay, so that's the first thing. And it's 30 degrees off of the vertical or 60 degrees off of the horizontal, regardless. That's a component. And then when you do this, you add a negative and a negative. It repels this way. Same thing. We've got two components, which means we have x's and y's, which means you have four components to worry about here. So one thing I like to do when you have this situation is I like to redraw it. And what I'll do when I say redraw, draw yourself your equilateral triangle again. So it's still 60, 60, 60, 0.15, 0.15, 0.15. The thing about this is that if I rotate this thing clockwise, this becomes my A, which means it's minus, so that's A. This one, okay, I've rotated clockwise, that means this one's my C, and this one here is my B. Now you can see that when I do this, again, I'll do it with some colors now. A and C, well, let's look at what A and C were. A and C, A is negative, C is positive. A positive and a negative, you're going to get attraction like that. And that's along the x-axis. So now already I've gotten rid of one component. When I do this one, between B and C, well, B is negative and C is negative, that means that you're going to have this thing go out this way. And that'll be at 60 degrees. So I've taken four components, made it into two components. So I've made it a little easier just by rotating it. So you're welcome to do it this way, but I'm going to do it this way. So let's do the force between A and C. So FAC. That's going to be 9 times 10 to the 9, and it's 8 and 2, right? Maybe I should write that in, hey? A is -2, C positive 8, and B is -4. And that's 0.15 squared. So that's FAC. Plug that in, you're going to get 6.4 times 10 to the 12 newtons, and direction is left. I'll also find FAB, which is going to be this one, which will end up being off at an angle. 9 times 10 to the 9, and it's going to be 4 and 2, 0.15 squared. That's going to end up being 3.2 times 10 to the 12th newtons at 60 degrees south of east. This is to the left, which is essentially an x-axis, so I'll call it x, which means that I'm going to have to break AB into x's and y's. So FABX is going to be 3.2 times 10 to the 12th cosine of 60 degrees. Remember, it's 60 and not 30 because you're wanting to come off the x-axis here, and that's where it is. So FABX is going to end up being 1.6 times 10 to the 12th newtons, and then look at your direction. It's got to be this way, which is right. So that's, I'll double line this because it's a component, double line that because it's a component. FABY, 3.2 times 10 to the 12th sine of 60 degrees. So that's FABY. When you plug that in, you get 2.77 times 10 to the 12th, and that's newtons. And let's look at the direction it's got to be. It's got to be this way, which is down. Okay, so now we've got all our components. I'm going to do a quick sketch, or actually I'm not going to do a sketch yet. I want to find my xt. So I'm going to come up here, add all my x's together. That is 6.4 to the 12th. It's left, so I'm going to call that left by just calling it negative. 6.4 times 10 to the 12th. And then this one's to the right, so I'll add it to 1.6 times 10 to the, where is it? Here it is, 12. So xt ends up being 4.8 times 10 to the 12th newtons, and it's going to be negative, but I'm going to call it left. And I'm going to give that thing a little cloud because that's my total component. My yt, I've only got down, so then it's got to be 2.77 times 10 to the 12 newtons down. Cloud that thing. Quick sketch. I've got to go left and down. That means this is my F net. That's the angle I want to find. So what I'll do is I'll just put in this is my X. So that's 4.8 and this is 2.77. I'll just remember that it's times 10 to the 12. But when I do my tangent, I'll get, the 12s will cancel anyways. Okay, so I want to find F net. That's going to be the square root of my component squared. So 4.8 times 10 to the 12th squared plus 2.77 times 10 to the 12th squared. And all square rooted. So your F net ends up equaling 5.54 times 10 to the 12th newtons at, and now I want to find this angle here. So that will be tangent to theta is opposite over adjacent. And remember the times 10 to the 12s will cancel. And we'll get a theta value of 30 degrees. So that's 30 degrees, and then it's south of west. And that is your answer for Coulomb's law and equilateral triangles. Quite a lot of work, but I guess the main thing is to get your components right. There you go.